Hey everyone, it's Matt from Crank Engineering, and if you've ever wanted to try TIG welding, you can find heaps and heaps of advanced videos on YouTube, but I haven't seen too many that cover the absolute basics. So if you want to get started with TIG welding, grab a coffee or a beer depending on where you are in the world, settle down, this will be a long video and we'll go through the basics to get you started. Okay, I've made a bit of a list of the things I want to cover, including setting up the machine, setting up the torch, selecting the consumables, setting up your workpiece, safety gear, and torch manipulation. So we've got heaps to cover, so let's get right into it. Now, if you bought your own machine, it may or may not look like this one. This is a few years old now, and this is an AC and DC TIG welding machine, so I can weld aluminium as well as ferrous metals like steel and stainless. So if you're only going to weld steel or stainless, you can get away with just a DC machine, which would be quite a bit cheaper and maybe a little bit easier to understand the panel. Some of the more modern machines have got just one dial and a switch, and that switch allows you to change between these functions and then you still adjust them however you want. So let's talk about connecting the machine up and getting it ready to go. First things first is you need to connect it to your power supply around your building or your shop. Now this particular one, because of the capacity of it, does require a 15 amp GPO or 15 amp circuit, which is not that common here in Australia. You normally have to get those wired in specially. So I know you can do the old fashioned file down the ground pin and make it fit in a 10 amp socket, but if you draw too much current with this thing, you'll probably trip your breaker, and worst case is you'll burn your house down. So don't be that guy. So make sure your power supply in your building is suited to the particular machine that you're using. Next thing you have to connect is your ground or your return cable. This goes back into my machine. Now on my machine I can change these over, so if I'm welding DC it's electrode negative, and if I'm welding AC it's electrode positive. So I need to be able to interchange these. So these just have a turn and you take them out. So on this particular one, this cable is the return cable, and I've just got to plug it into the right fitting depending on how I'm welding. It did come with a very cheap pressed metal clamp, which I thought was a bit nasty, so I just purchased this one. I think I got it on Amazon and got it shipped over, and that one has got just a big brass clamp, and I just think it's a better quality ground than what the standard one was with the machine. Next connection is your torch, and this is connected to a power supply obviously, and the gas supply, and there's a switch on this one to start and stop it. So there's an input to the machine for the switch. So on this particular front panel, the main power supply is plugged in here. The gas comes through the machine and out of this port and then into the torch. So it comes all the way down the center of the torch and out the tip. And this particular connection here is the switch input from the torch handle itself. So if I'm running a foot pedal, I can take that out and I can put the foot pedal in the next connector. Now, the guy who taught me welding was not a believer in foot pedals, and I guess I can see why now. Is you've got another thing to worry about controlling while you're trying to manipulate the torch and electrode. It just gets way too hard when you're beginners. So just skip the foot pedal for now. If you want to buy one with the machine, that's great, but just use a switch on the handle to get yourself started and then worry about using the foot pedal a bit later on. Now with TIG welding, you can't get away without using gas. That's what the G stands for, tungsten inert gas. So commonly you'd be using straight argon. Now there are applications for other gases, but for the sort of work we do on motorcycles, argon's just fine. Now, I don't know about your part of the world, but this shit is so expensive here, it's like gold. So I'm very careful with the bottle and with the connections and with the hoses to make sure it doesn't all leak out to atmosphere, and it cost me another $190 to get it refilled. So you're going to need some. Whether you buy disposable bottles or whether you get refillable bottles is up to you and the costs and the availability for what's around in your area, but it's essential. You can't get away with it. And if you've got argon, then you can weld pretty much anything you're going to be doing on a motorcycle. All right, let's talk about setting up the machine and what all these dials and switches are for. Now on this particular one, the on-off switch is right on the front panel here. So once I've plugged it in, I can turn it on and everything powers up. So this display here is used for, typically on my machine, for the welding current that you've selected. On the other side, we can switch between AC and DC. We can switch pulse function on and off, and I'll talk about that in a minute. And we can switch between TIG and manual metal arc. So this welder also is used for arc welding. So this is a great all-round machine. And 2T and 4T is to do with the switch on the handle of the torch, and I'll talk about that in a minute too. So just have a look in here on the panel between the rows of dials. There's a little drawing here, and it's actually a representation of the waveform or the current, welding current versus time. So let's go through the dials and hopefully it'll make a little bit more sense. So the first one here is called pre-flow time, and that's simply how much time will the machine flow gas before it starts the current. So I press the switch on the torch, and as soon as I press the switch, the gas starts flowing, and I can select from, I don't know, what's that, 0 to 1 or 0 to 10, whatever it is. And you can get some gas coverage over the weld to start protecting it before you light up the arc. So I put a couple of seconds on, mainly because gas is really expensive. Second dial across is peak current. So that's the amount of current the machine will output. And the thicker the metal you're working with or that you're welding, the more current you need. So that's just to select the peak current. On the next dial, we've got basic current. So if you're welding AC, then the current is alternating back and forth in different directions. So it's going one way, then it turns around and goes the other way. Well, that's the accepted convention. And the basic current means when it's going in one direction, it's at the peak current, and when it's going in the other direction, you can set a lower current level. So for an aluminium application, where you're using the reverse current to clean the metal, you might want a lower current there. So that's one of the controls used for alternating current or aluminium welding. And on this side here, the last one on this one is the downslope. So once I let go of this trigger on the torch, how long will it take for the current to go from the peak and drop down to 0? So you can use that function to help prevent cratering and cracking in your welds by tapering off the current slowly. If you cut it off really quickly, then the weld shrinks when it cools, and you can sometimes get a crater or you can get a crack. So that's just used for controlling the current as it's switched off. On the bottom row of switches, arc force has got to do with arc welding, won't worry about that one. There's two here for pulse, so pulse frequency and pulse duty. So this switch here is used for activating the pulse function. So at the bottom here there's a straight line, which is the straight current, and then on the top of the switch is like a sawtooth pattern. That's to indicate the pulse function. So I can turn the pulse function on, and then I can use these two dials to control the pulse function. So the first one's pulse frequency. So it's in hertz, which is cycles per second. So it's from 0.5 to 300. So that's how many times per second the current will pulse on and off. And then the second dial across is called pulse duty, and it's from 10 to 90%. So if it's at 50% duty, then it's on half the time and it's off half the time, if that makes sense. And if it was 75% duty, it would be on for 75% of the time and off for 25% of the time. So you can use these to adjust the pulse. And there's a couple of schools of thought that I've seen on the internet. One is 1 pulse per second, and the other one is 30-30, which is 30 pulses per second at 30% duty cycle. So if you've got a machine, give them a try at different settings and see what happens for you. The next one here is called cleaning area width. This is a function to do with AC welding. So you've got your peak current and you've got your basic current, but also what sort of percentage of time are you using the cleaning function on the AC welding settings. And then the last dial here is gas afterflow. It's measured in seconds, and this one's from 1 to 10. So it just lets you continue the gas flow after the current has stopped, and that allows you to shield the weld while it's cooling for a few seconds, which will prevent contamination and things getting into it. And again, because gas is very expensive here, I normally put somewhere between 2 and 5 seconds of gas after flow, which seems to work for me. Now, we didn't talk about the 2T, 4T function. 2T function is very simply when I push the trigger on the torch handle, then welding starts, and then when I let go of the trigger, welding stops. If I set this to 4T, then if I've got a very long, consistent weld to do, it lets me push the button once and let go, and that ramps the current up and starts the welding process. And then when I get to the end, I press it again, and it shuts it down, downslopes the current, and provides a gas afterflow. So it just means you don't have to hold your finger on the trigger for the whole weld, which can be useful if you're doing a really long weld, but the sort of work we do on motorcycles, that's not likely to be the case. So I generally leave mine on 2T and just hold the trigger down when I need the welding current to be on. Once we've got the machine set up, it's time to set up the torch to do the job that we're looking to do. And the first selection you've got to make is the correct electrode for the job you're doing. Now, I only carry 2 types of electrodes. The first one is these ones with the red mark at the end of the electrode. So I've got them in different sizes, 2.4, 1.6 and 1 millimeter. But these are 2% thoriated. That's a alloy, I believe, of tungsten. And it's specifically suited to ferrous materials. So you might be using these on steel, like on a motorcycle frame, or on stainless steel, like on an exhaust, but they're specifically suited to ferrous materials. If you're welding aluminium, then you've got these ones with the white tip, which are zirconated, which is a different alloy of tungsten, but that is specifically suited to welding aluminium. Now, I have seen advertised around some electrodes that are apparently all-purpose and you can use them for any material. I haven't tried them myself, but if you've got access to them and you want to give them a go, by all means, check them out. So once you've decided what electrode you're using, then the next thing is to pick one that suits the material thickness that you're welding. So if I'm welding really, really thin material, then I might just have a very small 1 millimeter or a 1.6 millimeter electrode. If I'm welding heavier materials, I might pick a 2.4 or 3.2 millimeter electrode. On motorcycles, generally I find I'm picking the 1.6 millimeter, or if it's a heavier material, 2.4. I don't tend to weld really thick materials with this machine. It's just motorcycle related parts, so a couple of millimeters, 3 millimeters thick material. So the 1.6 ones work just fine for me, and occasionally I'll grab a 2.4 if it's a heavier weld to do. In order to clamp the electrode in the torch, you need to have the internals of the torch set up as well. So there's a few parts in the center of the torch here which are all removable. So we've got an end cap that screws in the back, and you can get long ones and you can get really short stumpy ones as well. And these are great if you've got limited space where you're working. So if you're welding inside a motorcycle frame, for example, then sometimes the full end cap is just too long and you don't have enough space to get in to do the work you're doing. So the shorter ones are great. Then this is all part of the torch anyway, so there's nothing to worry about there. But depending on the electrode you're using, you'll need to get a collet body to suit, or a collet to suit the electrode diameter that you're using. So here's a 1.6 millimeter electrode, and this is basically a clamp that holds the electrode in place. So the hole here and the hole here are all 1.6 millimeters to specifically suit that diameter of electrode. And if you buy these collets in a kit, you'll find that you get all different ranges, a range of sizes for different electrodes that you might be using. So I generally, again, will be using 1.6 or 2.4, and you need to just select the correct one for the electrode diameter that you're using. So they're very simple to put together. Just stick this guy in the back, put the electrode in, and it screws in on this thread just here. So let's just screw that back in. And we'll put, because this electrode's worn down quite a long way, I could use my shorter end cap, so we'll do that as well. And the end cap just presses down on the back of this, which closes the front corner of it and clamps the electrode in place. So we can put the short end cap on, and I can just push this in and out to the distance I want. But first, before I do that, I'm going to put on one of these gas nozzles. And again, these come in different diameter outlets, as you can see from the selection that I've got here. And I generally just pick one that's either a 6 or I think this is a 7, so something like that. And these screw onto the body, so simply screw that guy in. And I was always taught to aim for about 6 millimeters or so of electrode protrusion past the nozzle. So you just push it in and out, don't clamp it down tight, push it in and out till you get to the distance out that you want, and then use the end cap and clamp it in. Done. Now all of these parts are considered consumables. So the collet bodies, even the caps to a certain extent, and the nozzles are all considered consumables. So I purchased a large kit with all these different sizes in it, got it quite cheaply online and had it shipped in. And sometimes you drop a torch on a concrete and you smash one of these. So some of these things are consumable. Generally the collet bodies I find are pretty good. They last a long time. And I bought this kit years and years ago and I'm still using parts out of it. I don't know, it was 30 bucks or so, maybe 5 years ago. So it wasn't very expensive, but all these little accessories help you depending on the job you're doing. Sometimes you'll need different sizes for different jobs. Once you've set up your torch, then you need to select a consumable filler rod that matches the material that you're welding. So they're probably hard to see in the camera here, but I've got 3 or 4 different types here for different materials. So these ones with the copper flashing, it's just for steel or chrome moly. They work fine for that as well. And they've got a copper flashing because they're basically made of steel, and if you don't put something to protect the steel, then they're going to rust in the atmosphere. And this particular one here in the center is an aluminium filler rod for cast aluminium, and these ones here are stainless steel filler rods. So they're very difficult to see, but in the corner of the rod, they often stamp the identifier or the material identifier. So this particular one says 316L, so 316 is a stainless steel. So this filler rod is made from a 316 stainless steel, and if you're welding 316 stainless steel, you'd use a 316 stainless steel filler rod to fill the material. Same with the aluminium. I've got a couple of different ones. One's for cast aluminium and one's for extruded aluminium sections. And you really need a different fillers depending on the sort of work that you're doing. So if you're working on just steel or stainless, well, you just need some steel and some stainless fillers. And if you're doing aluminium or you're doing brazing or any other job, then you need to find a filler material that'll match. So you need to go talk to your welding supply guy and tell him what you're doing and ask him for some guidance to match the filler to the material. Now, the only other variation you've got is, here's the steel ones, but there's a couple of different diameters as well. So 2.4 and 1.6. So if you're welding thinner material and you only need a small bead, well then you can get away with a smaller rod. If you're welding big sections and you need big weld beads, then you need bigger rods to fill it. You can use the smaller ones, but you just need to feed them in very, very quickly, and it's just a little harder to use. So you could pick a larger one to suit that job. So only in the steel do I have 2 sizes. Everything else I've only got 1 size. So you just need to find a filler that matches the job that you're doing. In terms of the gear you're going to need, it's pretty simple. A set of gloves like this are going to be very handy, and these aren't heavy welding gloves. They're quite thin pigskin or deerskin, I don't know what they are, but they're TIG welding gloves specifically, and they're thin, which means you've got quite a bit of dexterity when you're trying to move a rod in your fingers or manipulate the torch. So big heavy welding gloves, I find you really can't feel the trigger finger very well. You can't move the torch with the sort of finesse that you need when you're TIG welding. So you need to pick up some of these. They're not that expensive. Find them on sale somewhere at one of your welding supplies. You're going to need a helmet of some description, a welding helmet. I'm a fan of these self-darkening helmets. And this particular one is also variable shade, so I can switch it between a shade 9 all the way up to a shade 13. So the higher the current that you're using, the brighter the light. So the ability to dial this up is a little bit handy. On motorcycle jobs, not essential because you're not really welding with massive currents. And it's got a sensitivity dial on the other side here, so it'll decide how quickly or how much light change is required before it automatically darkens the shade for me. Now these aren't as cheap obviously as the very cheap fixed shade helmets, but it's just one less thing you have to do with your hands while you're trying to get the weld right. So I do think these are a great addition to your welding gear. Another thing that I will highly recommend is these little guys which are called TIG fingers, and you can get them from the Welding Tips and Tricks channel. Jody from the Welding Tips and Tricks channel prepares these, and I think he sells them on his store, weldmonger.com. These are great because if you're doing quite a long weld, I find that I'm resting my palm, I'm left-handed, so I hold the torch in my left hand. I'm resting my palm on the workpiece as I'm welding from left to right. And if I'm welding from left to right, I'm running my hand over the top of the weld. Depending on what you're welding and for how long, it can get bloody hot. So if you want to get some burns, that's the way to do it. But these Kevlar TIG fingers are designed specifically for that application, and you just simply wear it on one of your fingers. Typically I wear it on my pinky, and that means I can rest my hand on something that's hot and I don't get burnt. So you buy them in packs of 3, and I think they're a few bucks, I don't know, 10, 15, 20, I don't know. But I bought these years ago, and of course they don't wear out. So once you've bought them, they'll last forever. So great addition. I'll put a link somewhere so you can find these yourself. Before you start welding, you've really got to make sure that the surface you're welding is spotless. And I'm using this as an example. This is a piece of hot rolled steel about, I don't know, 2.5, 3 millimeters thick. And that's as rolled, so you can't really weld straight to that because that's mill scale on the top of the steel. So I've used a strip and clean disc, and I'll link to that in the video description. But I've used a strip and clean disc to clean this back to bright bare metal. And I prefer a strip and clean disc over a sanding disc because on thin sheet metal, if you're using a sanding disc, it's quite easy to thin the metal out. So I prefer a strip and clean disc for this job. And I just use it to make sure the steel is just like this, just bright and clean. And then the next step is to give it a wipe with some acetone. So a wet wipe with acetone, just to get off any oil, grease, whatever, even your oil off your fingers. So I'll just give it a wipe with some acetone. And I'm also going to wipe the filler rod that I'm using and make sure it's clean as well. So we're ready to go with those now. Next step is to prep the electrode itself. So this is quite a thin piece of steel, so we're going to use a 1.6 millimeter filler rod, and we're going to use a 1.6 millimeter electrode. So this is steel, so we're using the red tip ones, which was the 2% thoriated electrodes, and I've sharpened it on a belt sander to a very sharp point, which I'm hoping you can see in the camera. Now I didn't use my bench grinder wheel for this job because bench grinder wheels tend to pick up metal, and then they can embed that back into your tungsten electrode, and you'll be wondering why you've got shitty welds. So either use a dedicated wheel in a bench grinder for grinding tungstens, or like I do, use a belt sander to sharpen them. Now on a steel job like this, you just sharpen them to a point, and that's supposed to be, I don't know, 2 to 3 diameters. The length of that point should be 2 to 3 diameters, roughly. So just sharpen it to a point, and if it's nice and clean like that, we're all good. Now, the direction of the belt travel is this way. So I literally have the belt running and I grab the electrode and I just spin it between my fingers to get that point on there. Now, if I did it the other way around and had the belt travel in this direction and sharpen the electrode like this, what happens is I get circular scratches around the electrode, and that really screws up the arc. So if they're in this direction, then the scratches are along the axis of the electrode. So try and sharpen them with the motion of the belt or the wheel in same direction as the axis of the tungsten itself. Obviously we'll be wearing gloves when we move the filler rod, but I just want to show you the general motion most people seem to like, which is to grab the filler rod between your first two fingers and rest it in the crook of your hand like this, because it allows you to grab the rod with your thumb, slide your fingers up, and then feed the rod forward and repeat. So as you're welding and you're depositing the filler rod into the weld, it obviously gets shorter. So you have to keep feeding it. So I can back up and then I can feed rod forward. I know it needs to be very slow, or I might momentarily feed a little bit forward and I can move my hand a little bit as well. But you've got to be able to feed the rod, otherwise you run out of filler wire and you have to stop. Right, for our steel welding job here, I'm going to power up the machine. Now for steel, I'm going to weld with the electrode in the negative terminal. So there's a negative on this side and a positive on this side. So electrode's in negative. My gas is connected. My torch switch is connected. My ground cable is, I'm going to leave it straight on the bench because this particular bench I'm welding on is going to be the ground for the job. I'm welding DC, and I'm not going to worry about pulse, and I'm welding TIG, and I'm only going to use 2T, so switch on and then switch off. Right, so I'm going to put a little bit of pre-flow. Now the recommendation or the starting point or rule of thumb for the welding current is 40 amps per millimetre of thickness, or 1 amp per thousandth of an inch. So if I'm going to weld, say, 2mm steel, then I'm going to roughly start with 80 amps. So we'll just dial the peak current up to about 80. Don't worry about the basic. Down slope, we'll just put a couple of seconds of down and a couple of seconds of gas afterflow. And that's enough to get a basic steel job started. So let's head over to the welding area and run a couple of beads. When we're manipulating the torch and the filler rod, the generally accepted idea is to keep these at 90 degrees. So the electrode is obviously in this direction and the filler rod should be, give or take, at 90 degrees to the electrode. So how that translates in operation is the electrode's going to be close to the surface and you're going to be tilted slightly away, and you're going to be feeding the filler rod in roughly 90 degrees to the electrode. So this is only, I don't know, 15 degrees or so from the horizontal, and keep it at 90 degrees, and that's about the angle that you'll be working at. Because the motion of the electrode is so small, and I like to think of it like writing. The motion of a pen is very small, and the motion of the electrode and your TIG torch really has to be equivalent to handwriting. So we're not making big motions with the electrode, and the torch, it's only very small motions. So your body position has to be such that you can accurately direct the torch and the arc exactly where you want it. So I often find I have to lean on the bench with both my arms on the bench and prop my body against the bench so that I'm nice and steady. So you need to find a position where you can very accurately move the torch in a similar fashion to handwriting. All right, so let's get ready to run our first bead. I'm going to hold the torch at a slight angle to the workpiece or the steel I'm welding, and I'm holding it about 2 or 3 millimeters from the surface of the metal. Now obviously if I move my finger or hand a millimeter, it moves the tip a long way, so I've got to be very, very steady with this activity. we're going to light up the arc, and we're going to wait until we can see a pool of molten metal. And then we're going to move the torch forward a little bit, and we're going to very slowly walk along the plate here, and just what we're going to do is melt a pool in a line before we worry about putting any filler rod in. So let's give it a go. Alright, so what we did was we melted the steel and ran along in a straight line. Now you did see that nasty little burst at the start. It was probably some mill scale or something still on the steel, which caused that little fart and a bit of a dag there. So this is not steel I'd be using on a motorcycle, but for the exercise it's fine. So now we're going to go back, repeat this exercise, and we're going to start to slowly add some filler rod into this to build up a weld. Okay, you can see the weld beads where I've added the filler rod. Now this is very flat, this bead. If you look on almost on side view, it's pretty much flat. So I would be turning the heat down on this job because there's probably too much heat. And if we flip it over, we'll see that you can see it's starting to penetrate through the back of the plate here. So, okay for the exercise, but I would dial in the heat back if I was going to continue this. Okay, so let's just recap what we did here. So we start the torch, melt the surface of the metal we're welding, and then we dab the rod into the molten pool. And then we pull the rod out, we move forward a bit, and then we dab again into the molten pool. So we're not actually melting it off the end of the rod with the arc, we're dipping it into the surface of the metal that's already molten. So melt, dab, melt, dab, melt, dab, melt, dab. Now the consistency with which you move and the consistency of your adding filler metal to the molten surface is what dictates the final appearance of the weld. So if you're moving consistently and you're dabbing consistently, you'll get consistent looking weld bead on the surface. If you're not, then you'll get something that looks a bit more haywire. So it's just one of the skills that takes a little bit of practice in terms of your motion and your coordination between your left and your right hands. Forgot to mention that I will take all of those items I talked about and make a checklist out of them that you guys can download off my website. So have a look down below somewhere, there'll be a link, but that should help you at least remember all the things we talked about today. Thanks for watching. All right, we've covered a heap in this video. I hope it was enough to get you started with your TIG welding. If you've got any questions on the stuff that I didn't cover or didn't cover enough, please hit us up in the comments below and I'll get you an answer back, or I can follow up with another video at a later time. Hopefully it was useful. Thanks for watching. If you liked what you saw, give us a thumbs up. And if you want heaps more videos on customizing motorcycles and the skills you need, just hit that subscribe button and we'll see you next time.